Today we have a tech talk by the team that built Yahoo Pipes. Pasha Sadri, Jonathan Trevor, Edward Ho, and Daniel Raffel. And there's a wonderful quote by Tim O'Reilly. He says, "Yahoo's new pipe service is a milestone in the history of the internet. It's a service that generalizes the idea of the mashup, providing a drag and drop editor that allows you to connect internet data sources, process them, and redirect the output." So now we get to see whether Tim O'Reilly was right. Here's Pasha.
Hello, testing, okay. Hi, everyone. I have to say it's an honor and a pleasure to be here giving a Google Tech Talk. Our talk today has two parts. The first part will be by me. It will be a high-level overview of pipes as a product. And the second part will be by Jonathan Trevor, who's going to give you some of the details about the implementation. And it's great to see such a turnout at relatively early on Monday morning. All right, so with that, I'm going to start my part. So the story started a few months ago when I was looking for an apartment. Not just any apartment. I was looking for an apartment near a park. Now, if you think about how you would go about doing that, it would probably go something like this. You'd go to Craigslist apartment listings, and you'd go to, say, Palo Alto Apartments. You'd go down to each listing, click on the map link, and go to Google or Yahoo Maps and check to see if that apartment is close to a park or not. As I soon find out, that's a very tedious process because there are new apartments constantly posted on Craigslist, and to probably go through 20 apartments every day, it's very time-consuming. And being an engineer, I immediately started thinking, well, how can I solve this problem for myself? Technically, it's possible because Craigslist has a RSS apartment feed for any of their searches. And you can use a service like Yahoo Local to search for parks within a certain geographic region. And I could actually write a little Perl script to mash up the two data sets together and solve this problem. It took me about an hour or two to write and debug that script, and I had it going. But of course, again, being an engineer, I started thinking, how can I further generalize this? So my script was basically taking one data feed and mashing it up with two web services, the Yahoo Geocoder web service and the Yahoo Local web service. In other words, this was a mashup that I had to write. And as you know, mashups have been on the scene for the past several years. Housing Maps and Chicago Crime are two very well-known examples of mashups that people have built recently. But now, wouldn't it be nice if there was a more generic way of creating mashups, of taking feeds and web services and combining them to make more useful information out of what's available out there? So this is where Pipes enters the picture. Pipes is a free online service that lets you take data feeds and web services and mash them up together to create new data feeds. And hopefully that data is more useful for the end user or the developer, whoever's putting the pipe together. So going back to the example that I started with, Craigslist and Yahoo Local, both of them provide some kind of a API access to their data. And the only thing that we really need is some kind of a glue that allows you to combine that data and manipulate it as we need. So with that, I'm going to give you a little demo of the apartment near something. Actually, we didn't test this before we started, but. So this is a pipe that I built, and this is one of our example applications built in pipes. It is an apartment search application that uses Craigslist and Yahoo Local, and I'm telling it to search for apartments in Palo Alto and filter out the ones that are not at least within 2 miles or, let's say, 1 mile of a park. Should have hit the run pipe a little bit earlier while I was talking. So this is going out to Craigslist and then geocoding all the Craigslist apartment entries and then doing for each apartment, doing a search on Yahoo Local to find nearby parks and doing a filter on the output. As you can see, I can actually click. The results are coming from Craigslist, and hopefully this is within a mile of that park. So we can now drill down into how this pipe was built. I'm actually going to create a simpler version of it first. So first, let's start with Craigslist. You can go to apartments, Peninsula, search for Palo Alto. Okay. So if I scroll down, a lot of web pages have this RSS symbol down there, which is very handy. I can put in an RSS or Atom or RDF URL into the fetch feed module, and it will immediately go and retrieve those results for me. Now, these things don't have geolocation in them. So we need to, the first thing we need to, in order to enable something like apartment near something, we need to geocode them. We have written a location extraction module that tries like a dozen different ways of trying to figure out what's the location associated with an RSS item. So I connect these two together and run it again. Ooh. And if I drill down, we see that each item has been annotated with a Y location, which denotes the location of that item coming through. Now, we have a looping construct. Can connect these ones up. Now, for each apartment that's coming through, I want to do a Yahoo local search. And basically say, find parks within 1 mile of. Well, this is doing a lot of web services right now in the back. Say 5 miles. So now the output of this nearby park to refresh. So what this is doing is for each apartment, doing a loop and doing a search on Yahoo Local, using the location of that apartment and searching for parks within 5 miles of that, and annotating that item with the first result that comes back from Yahoo Local. I can show you where that is. So the nearby park is now an object that was returned from the Yahoo Local search. And it has this handy distance element, hopefully, yes, which I can use to later filter out the apartment on. So the last thing I need in this pipe is basically a filter. Oops.
That's a mobile home park. Is that what you want?
Oh, OK. So that's what I was going to say. This is a simplified version of the demo. In the full-blown version, the actual Yahoo Local result set is wrapped in another set of filters that actually make sure the results are parks and not just mobile parks. But this is a simplified version for the, that's the like 1 or 2 hours I spent debugging my Perl script. Half an hour of it was about the mobile home parks. The last thing I just need to do is the nearby park distance is, say, less than 1. And that's the pipe output, finally. I can now save this thing. when we save a pipe, we actually execute it in the back end and annotate it with all the different data sources that it uses so that we can offer navigation on the public pipes.yahoo.com site so that you can say which pipes are using, say, Craigslist apartment search. You can run to the preview. And this is going to actually run that pipe for me and show me the results. So putting together a pipe is pretty much as simple as that. I can use this pipe for my own use. I can take the output as RSS or add it to various RSS readers that are out there. Or if I want to use it programmatically, we also offer a JSON output of the pipe output. Now, the next step after this becomes if I think that this pipe might actually be useful for other people as well. It would be great if I could somehow share it with other people. Right now, the values parks, Palo Alto, the distance to the park are all hard-coded in my pipe. And that's not going to be very useful for a lot of people unless they're looking exactly for the same thing. But there's a way to actually parameterize things in pipes, which makes these more reusable by other people. So I'm just going to show you a quick example. Here I'm searching for parks. I can actually parameterize that. Say parks. Any place that I have a hard-coded value, I can actually drag in a variable. And let's do. So instead of parks, I have a user input. Save that again to see the result. So this time when I try to run the pipe, you see that we have auto-generated a user interface for that pipe based on all the user input elements. And I can send this URL, which is publicly accessible, to my friends. And they'll hopefully be able to use this pipe to do something useful. So that's the demo portion of pipes. I'm going to jump back to the presentation. So now that you've seen that, the example that I gave just used one feed and 2 web services. But in fact, there are probably millions of feeds out there and thousands of web services available. So if you think about all the combinations that are available to be made from these services mashed up together, you kind of get a picture of what's possible or why people are excited about pipes. Certainly, we are excited about it. And in fact, there's been all these great services that have been offered over the past few years, Gbase, eBay, Yahoo, and what they have in common is that they have all these APIs available. And while they cater to their own audience very well, they still leave a lot of unmet needs in the form of the spaces between these services. And Pipes aims to fill up these spaces by creating mashups between the different data and services available out there. So now you know what Pipes is all about. I'm going to talk a little bit about our design philosophy on putting it together. So the first thing, we borrowed heavily from Unix pipes. In fact, the name Pipes is a play on Unix pipes. As many of you know, Unix pipes basically allows you to combine very basic primitives and build up useful applications. This is a model that has worked very well in the Unix world for the past, 50 years. And we thought that since we are basically processing streams of information, it could very well apply to feeds that are available on the web. Our goal in general was to build the minimum number of modules that enable the maximum number of applications. So a lot of our built-in modules in pipes very closely follow the Unix standard, grep, unique, sort, etc., things like that. The other part of our design philosophy was to work with as many different input sources as possible. So I've shown some example services. In terms of formats, we support RSS, Atom, JSON, and just recently arbitrary XML data structures. And we hope that people who have some data that they want mashed up, and we'll offer it in a way that can be used through pipes. The other design philosophy is to support as many different output formats as possible. So currently, we support RSS output. We support JSON output. You can subscribe to receive email alerts or SMS alerts. Or you can put the output of a pipe in a widget or a badge that you can put on your website. You can put it in a reader. You can put it on your personalized homepage. We have a hosted version of pipes that you can come and execute a pipe. The rendering is similar to web result set. And if the output feed contains geo information, you can actually plot it on a map. So the general attitude has been to try to support as many different output formats as possible. And we hope that people are going to start using the output from pipes in their applications, just as another element in their data processing pipeline. And finally, we have this idea that we want to have an open processing module. We have a number of built-in processing modules. It would be great if you have a web service that does some transformation on data. You can plug it into the Yahoo Pipes service and expose it there so that other developers can be aware of it and use it in their pipe applications. So overall, by supporting any data input, any kind of processing, or any kind of use of the data output, we are aiming for a very open architecture where we work with anybody's data and we allow the data to be used by anybody who's interested. And the general idea here is that by supporting the maximum number of inputs, processes, and outputs, pipes will become more useful to people. The more of those that we support, the more number of combinations that are possible, and some of those are bound to be interesting. So some of the examples of interesting pipes that have been put together recently that we are aware of. One of them is a data mashup between Last.fm and Flickr. So somebody took, actually Mr. Speaker, I don't know the real name of that person, took the data feed from Last.fm, which is the recent tracks played by a user, put it through pipes and looked up, using content analysis and Flickr API, find pictures related to each artist that was being listened to by that user, and took the JSON output and piped it into a Grease Monkey script that inserts a badge back into Last.fm. So as you're browsing around on Last.fm using this Grease Monkey script, each user's profile page gets augmented with this badge of their Flickr images. This is one of the more interesting examples because it uses so many different components. And I'm happy to see it. Another interesting example was Second Life. This is sort of, I didn't expect pipes to end up in Second Life, but Max Case built a translation service because in Second Life you're likely to run into people who don't speak your language. So he built an object that does translation between different languages, and the actual translation is done through a set of pipes. And that's it for my part. And now Jonathan's going to talk a little bit about the implementation.
Okay. Thanks, Pasha. OK, so when we were creating this originally, we actually had a significant advantage over a normal website approaching this. One of the assumptions we could make was that we were targeting the top of the Web 2.0 pyramid. So right at the top, you've got the 1% of developers, which is probably like 99% here. Below that, you've got the remixers and the bloggers, another sort of 8 or 9%. And these are the people that we actually wanted to target. So because we could do that, we could assume a lot of prior knowledge. We could assume they're sort of familiar with publishing, the idea of getting these things out there. We could assume they're familiar with loops and typecasting and putting things together. Even the notion of a mashup is fairly familiar to these types of people. So while the developers are the people we were targeting here, and they're the people that are going to benefit directly, is the people who are going to consume the outputs of these pipes, whether it's in a badge or whether it's in a map, they're going to get indirect advantages of this. So this is the sort of 50,000-foot view of the architecture, and there's nothing very surprising here. Obviously, the sources at the bottom are the most important things that we have. Without the sources, pipes doesn't do very much. This is where all the data comes from. We have an engine, which is where all the heavy lifting's done. This is where the mashup and the pipe definitions are run. We have the website, which is where our community, this is where you can find pipes, this is where you can build pipes, this is where you can run your pipe. This is the place where most users actually interact with the system. And then finally, on top of that, we have the clients, whether these are badges, whether this is a web browser, whether it's part of another application. The point is we don't really mind what consumes pipes, we just want to make it possible. So the engine itself, again, the heart of the system, this is where it takes a definition and it does all the hard work. This is where I built the editor. This is where I just get to say, oh, there's some problem with the back end when it goes wrong. That was my good answer generally. So pipes are defined by a very, very simple definition format. It's nothing very elaborate. It's literally what you see in the editor it pretty much goes down to the definition format. And the execution is parallelized as much as possible for performance. Clearly, caching is very, very important too. So in the previous architecture, I didn't show the cache layers, but we have caching everywhere to avoid us pummeling the services with too many requests, to avoid us going out to other places, basically to keep it going fast. So while we were pitching this very much as an RSS service, the engine itself doesn't care about RSS. It's really processing XML or JSON or data, sort of structs, arrays, and scalars. So it's not really limited to RSS, and that's something we'll be exploring in the future. So the editor is where the pipe definitions can get created. It basically just posts them back to the engine. So while the editor is this nice, great, fantastic thing that people can use to create pipes very rapidly, we could actually write them by hand in a text editor. They're actually not that complex. The heavy lifting, all done by the engine. The editor's a very thin view on top of all of that data. Errors are all thrown by the engine. Executions are all done by the engine. The editor does some type checking to make the users actually do the right, to not create bad pipes, but for the most part, it relies on the engine. One of the things when we were starting out was, one of the things we observed is that now browser technology has moved on so far that there's very little that's no longer possible. When we started off doing this design, we never said, oh, we can't do that because it can't be done in this browser, or we can't do that. We had a very open mentality, and I think that's something that we're going to see more and more powerful applications like the editor coming out. So one of the things we were very keen on doing was to make sure the editor was easy to use. We're targeting the top 10%, and the top 1%, I'm sure, could probably make do with a basic tool. But the remixers, the bloggers, these other people that are further down the Web 0.02 pyramid, we really want to support and make things easy so they can just do these mashups as they want to. So we did this in a number of ways. One was to highlight target affordance. So when you're dragging the lines around, the lovely curvy lines, that you're not just randomly connecting them to different terminals in there and just hoping it'll work. It actually shows you what are the valid terminal types that you can connect to. This was more of an accidental discovery, but it's something that once we realized we were doing, we were keen to keep going. And that's of a left-to-right readability. So when you're browsing and looking at a pipe, you may not understand at a glance what it's doing, but you can have a look at a module and just read it to sort of get some basic understanding of the actions it's performing. So the example here is find pizza within a certain amount of miles of a location, Santa Clara. One of the other things we were very eager to support was to avoid people going away from the editor. It's if you're going for this whole ease of use thing, the moment you have to leave the editor, change state, open another web browser, it's really blown the whole experience. It's a lot more fiddly, it's a lot more painful. So one of the ways we avoided people having to leave the editor was through inline searching. So this is sort of insta-search. So you can just type in the name of any keyword for a feed or a pipe, and it appears in the top left of the editor, and you can just drag that on as a source module. The other bit that proved very, very important was what Pasha was demonstrating is the inline debugger. So every single module at every single stage of the pipe can just be clicked on and inspected instantly. There's no, I have to change page to debug it. I can just click and see what the output is, tweak the module, refresh, run it again, and I've seen what my effects have done. There are a few other people that are trying to do similar sort of things in the space, create mashups or trying to do data processing and data editing, data flow. One of the things that differentiates us is the instant on. So the moment you put a user, the moment you ask a user to download something and install something, you're going to lose people. You've already made that experience a lot more painful than people like. Nowadays, again, with the sort of assumption that you can do everything in a web browser, we wanted to support this instant on experience. So with the editor there, you saw Pasha bring it up. You just clicked on Create Pipe, and any normal browser will just pop up the editor, and you're away. There's no delay. You can just get it going. Data flow applications are clearly very well suited to visual editors. So I'm sure everybody here is familiar with sort of linking up audio flows or video flows in processing systems. That was something that we capitalized on. And finally, one of the big things that's actually helping our success at the moment is the view source approach. So HTML was, when it first came out 15 years ago, 10 years ago, was not many people didn't know what it was. There was very few tutorials. But what you could do is you could go to a page, you could see something that was sort of what you wanted. You thought, yeah, that's pretty good. You could right-click, view source, copy it, paste it into your page, and now you had that. And now you could tweak it a little. You didn't really understand what the tags did, but you could tweak it, and it looked nice, and it presented the information you wanted to present. So one thing that we do is every time you can see a pipe, you can always visually inspect it. You can see how that pipe runs. You can then copy that pipe. You can add that to your own library. You can make the tweaks. So pipes can propagate that way. And what this leaves us with is an IDE-like editor that we hope many people can use. During our launch, we found that we were possibly pushing down much further in the pyramid. We were getting people who'd never coded before using the editor to put pipes together, which was a great win for us, something that was a very pleasant surprise. Now I'm going to talk a little bit about the wires, one of the more technical parts of this talk. So Firefox, Safari, WebKit, Opera all support Canvas natively. Canvas is just a 2D drawing layer. You can draw Bezier curves, you can draw rectangles, you can draw any type of 2D shape on there. IE 6 and 7 don't, but thanks to you guys, we didn't have to worry about that. So thank you very much. And there's obviously some docs on the Mozilla site for how to get going with that. Now, because it's in a web browser, obviously we have issues. Nothing ever works properly in a web browser. You're always fiddling with something. So there are lots of cross-browser issues. If you're just doing static canvas tags, there are very few issues. But the moment you start resizing the canvas and wanting to do those things, you hit a number of issues. So in Safari, you actually need to completely destroy the canvas and recreate it from scratch every time you change its size. In IE, your wrapper doesn't actually clear the canvas when you want to draw different lines on it, so you have to manually clear it. So there's a host of little problems, but they weren't a big problem. CSS is an interesting problem. So nowadays, we're used to separating out the visual language from the actual structure that you're putting on the page. And canvas tags are just drawn using JavaScript, which is sort of code embedded in the page that's loaded. So it's very hard to tweak the look of something without going into the code and just redoing it. So rapid evolution when you're trying to create these things is very difficult. So that's just something to be aware of. Performance is an issue with the canvas tags. We gain some advantages by assuming that developers are going to be the people using our tool, because developers actually tend to have higher-end machines and tend to upgrade their browsers fast. So that's a nice little side effect that we got. The biggest problem with performance is the moment you have any transparency and overlapping canvas tags, the performance just disappears. It's really nasty. So that's something you have to avoid. And the biggest problem with the canvas tag is that because you might be drawing a nice, simple, thin line, but it's actually taking up the full bounding box of a rectangle. So the moment you actually put these on top of anything, you've just swallowed all of your DOM events, and you can now no longer interact with anything on there. So this is one of the biggest problems that we had. And we reiterated several times. I just want to spend a few minutes on that. So first of all, we started off with a simple one, which is the lines above. This is actually the design we wanted to go with, so you could exactly see where the lines were hooking into the modules. Unfortunately, all your events get swallowed. You get no hover events, you get no click events. Everything's swallowed underneath these lines that are at the top of your DOM. So one thing we started to do was to manually dispatch the events into the browser using some custom JavaScript code. And I can tell you that's a really bad idea. It just doesn't work. It gets gnarly across browsers very, very rapidly. Hover things are almost impossible to calculate. Mouse in and out, very, very difficult. If we could somehow get the W3C to implement a tag that's like ignore events on this element, that would be really handy. So we abandoned that one. Then we put the lines underneath. And obviously, the lines underneath, you have the problem that you can't actually see the lines going into the modules. And then if you drag the modules, we wanted to raise them up so you could at least see where they were. That worked OK. But again, you just couldn't see where the lines were in this other mode. And when you raised them up, you lost all of your interactivity again. So it's still the same problem as before. The moment they go to the top, you couldn't drag a line onto something and drop it if there was another line that was obscuring it with its bounding box. Then we played with a couple of ways of making the modules transparent. So the idea here is that as you look at a module, you can see a line going underneath and entering it. So this would solve our problems. You could see lines going underneath modules. You could see where they connected. Visually, it works. Unfortunately, the problem with performance that I talked about earlier is a huge problem. The moment we make modules transparent and you start to move them around, performance drops to single frames a second. The solution that we tried for a while was to make the modules solid on drag. So we leave them sort of semi-transparent to start with, so you can see all the lines, but they look a bit faded out. And then when you start dragging, we just make the modules solid. And this actually turns out to be a really, really weird effect. It means that when you're in a transient point in the user interface, everything gets solid. And when you've finished, everything sort of fades away to look a bit washed out. So we had that one for a while, but in the end, we decided that wasn't the way to go. So the solution we went with in the end was this sort of a again, lines on the bottom, and everything remains solid. But the moment you mouse over the bounding box of the line, so this line's bounding box would be sort of this square here, and this line's bounding box would sort of be like this square here. When you mouse over the lines, the modules at either end fade out, so you can at least see where the connections are for the line that you're over. So that allows you to sort of see where they're going into a module, but we keep the advantages of them being on the bottom. So I'm going to finish up by talking about some of the ongoing challenges that we have, and I think are very interesting. Every time we look at our feature requests, there are more and more feature requests for scripting support, for doing more and more things with pipes. And what we're fighting here is an ease of use versus power. So many people can come to pipes, non-programmers we've seen can come to pipes, start using it, build their own data mashups, put them on their own site, create their own content. But the more powerful we make it, the harder that gets to be. And that's something that we have to be aware of at every step of the way. We have this problem of scale at the moment. We're getting all of these interesting pipes created, but how do you actually find the right pipe for you? How do you dig down and find the one that's a component that you can use in your own pipe, or uses the API that you want to use? So discovery, bubbling things up with sort of interestingness, like Flickr does with photos, it's something we need to address. API rate limits and keys are just a small but significant technical issue. We execute everything from this engine. It only has a finite number of IP addresses, and most APIs are IP rate limited. So that's something we need to think about. And once users have their own accounts and they want to do processing on their own data, we enter sort of an authentication problem. So if I want to do something with my email and read it through, say, the Cascade API that Yahoo has, that's great, but then how do I give the credentials to the pipe? How do I make sure that if that surfaces as a badge somewhere, that somebody else can't read my email? So there's lots of joyous issues with authentication. So last week we added support for more data formats, not just RSS. So now we can take in XML and JSON. So it's any type of XML, whether it's KML, REST, and so on. So there's a new fetch data module. The output of the system at this moment is still RSS or JSON, but the input is now pretty much anything. Coming soon, hopefully we'll get this extensible module for doing arbitrary processing in the middle of a pipeline that Pasha talked around. And we're going to have some just more easy to pick up renderers just to make it easier for the end users that are coming to our site, not the developers, which is who we were aiming for, but the end users who had just found a pipe that they want to add to their blog. As a badge, they can just pick that up and use it. So what pipes has allowed many people to do is to solve their own individual personal problems. You can, lots of people are solving the big problems, but the problems that I have, like searching for a sofa of a certain type within 10 miles of my house so I can actually get it home, it's pretty much unique to me. Nobody else probably cares about that, but it's a really difficult problem to build and solve. But with pipes, I can build that instantly. I can start addressing these very high-value problems that I have that are very small and focused. We started to see something like user-generated features appearing on websites. So this is where if somebody actually provides a mashup between various sources, the application provider can take that pipe, doing that mashup, and insert it back into their own site. So you're starting to see that people are building parts of applications that are sort of being pulled back in. And we might be entering, this is a very overused word at the moment, or overused phrase, but disposable applications. It really is easy for me to build something that I may only run one time, I might run it 2 times, I might share it with 3 people, and then it's done, but that's fine. So we might be entering a new era of disposable applications. So thank you, and I'd love to take questions.
So I think the real question that everyone wants to know, Pasha, is did you find an apartment, and is it near a park?
Well, it was somewhat of a hypothetical example. I did actually find an apartment. I live in Palo Alto, and there are a lot of parks, so you can't help but be close to one. But the output of the pipe works,
Okay. So I have a real question, which is about caching. And I want to know, do you run these pipes just when the output is requested, or do you do some continuous processing in the back end at different layers to keep the data flowing?
No, we tend to do it on request. We don't do any continuous processing at the back end. But obviously it goes through many caching layers, so when it's requested a few times within a certain time frame, you'll only get a cached version of it.
I think the reason for that is much of the web actually works on the pool model, and we felt that just continuing with that is probably the simplest pass on this problem.
To follow up on that, I'm really curious about the performance impact you saw in general, both throughput and user latency. Like, for example, for cold pipes that haven't been requested recently, you could possibly need to go fetch 10, 15 RSS, RDF Atom sources. Do you see poor end-user latency? Do people care or not? That kind of thing.
So we try to address that problem as much as possible by parallelizing the execution of the pipes. So if the pipe relies on 10 independent data sources, we try to fetch them simultaneously in parallel. And we do run into the cold cache issue occasionally. Some of the more popular feeds are obviously shared amongst many pipes. So the caching layer is basically a transparent caching web cache layer. So we sometimes get hits on popular sources. The other thing, the problem is somewhat mitigated by the fact that the output of the system is RSS, and it's often put into an RSS reader. So it is fetched asynchronously on the user's behalf. So the next time that, well, if you wanted to use it in a sort of a real-time application, it would become more enough an issue. We can probably do some things to further optimize the fetch sequence of feeds, or even one day be more proactive that we know that you're requesting a pipe every 10 minutes. So we try to keep up with the data sources as they're updating.
More of a high-level question. How do you see this fitting in with Yahoo's kind of overall API/developer strategy?
Well, I think actually Pipes fits very well in there, because what Pipes does is expose a lot of the APIs that Yahoo has developed in a very easy-to-use format. I think we've seen an increased usage level of many Yahoo APIs that are featured in Pipes. I want to add that we didn't intend pipes to be Yahoo-centric in any way, and we've made a point of including a Google-based module in our default module list just to illustrate that point. Hopefully, over time, you'll be able to add more third-party modules in there. As I mentioned, I think the power of pipes comes from being able to work with as many APIs that are available out there.
What kind of discovery capabilities do you have for finding feeds, finding existing processing, and stuff like that?
Yeah, I mean, there's one weakness we have now. The current website, you can basically browse by something like popularity, but that's not really a good way of actually defining a useful pipe for somebody or somebody to find the right pipe that they want. We do store a lot of information about a pipe once it's run, which is why the save is a little longer than it might be. So we tag what sources it was fetching. So you could find me anything that uses google.com and pulls from that source. We do have a service at Yahoo for searching for feeds. So we do bring that into the editor. I talked about that briefly. So once you type in a few keywords, it'll try and bring in the link to that feed, and you can just add it to that. But discovery is a problem at the moment for us.
It wasn't clear to me, but is there a way to join two sources in your pipes?
Yes.
It is.
You mean as in a SQL join, or just merging the streams into each other?
Sort of merging and sort of doing something on the union of the two streams.
So let's see. It's certainly possible to combine two feeds into each other. I can, for example...
Yeah, there's a union operator, I saw that. But sort of does it let you get items from two feeds that have some common element and then do processing, which is on data from both the feeds?
I see. So you mean take two items from different feeds and then maybe merge them into each other, or...
Yeah, create sort of one item out of it and then do some processing on it.
So we used to have a join module that was too complicated to explain to our initial target audience. We may reintroduce that back in once we've simplified a little bit. We have an extensible system where we can introduce new modules. So if you have a request, actually, for a module, it sounds like one, please, we'll be happy to get in touch with you and try to implement it.
I mean, while you were giving the talk, I was just thinking of an example that look at the news articles and get images corresponding to keywords in the news article. So that would require a feed from Flickr and some news source like BBC or Yahoo News. Or
Yeah,
Google.
so that simple case is possible. We have a for each annotate where we loop over items in a feed and then annotate each item in it with the results from another service or pipe. One of the things that I didn't actually show is the capability of using pipes to extend itself. So I'm logged in here and my pipes are listed here. I can actually use a pipe that I've previously built. I can open this. So this is actually a pipe that does a more sophisticated version of the Craigslist apartment search. And I can actually use it as a data source in another pipe. So one of our aims is that hopefully there will be a library of these reusable components that people can build more high-level pipes on top of. But in this case, you can actually do something like for each annotate and drop a, say, Flickr module or any kind of source module. Okay. And each item going into the for each module will be annotated by the results of the inner module.
Oh, thank you.
Sure.
I think that's it. Thank you very much.
Great. Thank you.
Thanks.